Last part of 7.5, we're talking about inverse function values. So the first ones that we're going to cover is covering using a calculator and how to find the inverse trig function. So we're looking for the angle. Remember, that's what inverse trig functions do. They find the angle. So here's a couple problems. Okay, so we're finding the inverse of cosecant of -1. Inverse cosecant of -3. So since this is the reciprocal of sine, I'm not going to do 1 over cosecant for sine, because remember, sine of theta equals 1 over cosecant of theta. So the theta does not change, right? I don't flip my answer here. What I do flip, if sine of theta, say, is 3/4, then cosecant would be I would do 1 over 3/4, so cosecant would be, so if sine equaled 3/4, then I'd flip this and get 4/3, right? So those aren't actually equal, but so I would flip my answer, right? So that means I'm actually going to flip this -3, so I'm going to get 1 over -3, and then I'm going to do the inverse of sine on my calculator. So I hit shift or second sine, and then I type in -1 divided by -3, and I get approximately -0.3398. And so this is in our range. So this is in radians, right? So in radians, sine needs to be from -pi/2 to pi/2, and that is in our range, right? So this is an acceptable answer. Okay, the next one we can look at putting in degrees. So find in degrees, find the arc cotangent of -0.3541. So here, remember, our range for cotangent is between 0, 0, and pi, right? So our answer has to be some between 0 and pi. But we want that in degrees, so that'd be 0 and 180. Okay, so same thing, we're not going to flip cotangent, we're going to flip this answer, and then we can do arctan or tan inverse. Same thing, 1 over -0.3541. So when we put that in our calculator, we get this answer, approximately -70.5, so that's in degrees. Correct? So since that's in degrees, but we are -170, right? So that means our answer is, say, somewhere it looks maybe down here, so -70, maybe about right here. There's where our answer is. Okay, but we want that in this top quadrant, right? So, well, cotangent will have that same answer 180 degrees away. That answer right here will also be true, because cotangent's negative in this quadrant and negative in this quadrant. The answer is negative, right? I'm not talking about degrees here when I'm looking at this negative or this negative, but they have the same value. Okay, so at this point down here in the fourth quadrant, we'll have the same value as this in the second quadrant. So if I add 180 degrees to this -70, so if I add 180 degrees, then I will get actually a positive angle in the second quadrant, right? So if I add that, then I'll get to the 109.5 degrees as my correct answer. So I needed to add 180. And you usually have to do that when you're dealing with stuff that comes out in the fourth quadrant and you're trying to get to somewhere where you need your range in between. So sometimes you might have to add 180 to that answer that you get on your calculator in order to find out. Make sure you be in that range, right? Okay, so here are some other problems. These ones are kind of fun. I probably should put parentheses over this, because this is taking sine, so I'm taking sine of tan inverse of 3/2. So what that means is that I am finding the angle. So there's kind of two different ways to do it. So I'm taking sine of an angle, right? Because tan inverse is actually finding the angle. So this just represents some angle, say A. So you could draw a right triangle and label an angle A, or theta, or whatever you want, right? And now we're doing tangent. Well, tangent is opposite over adjacent, correct? So the opposite would be the 3, and the adjacent would be the 2, so opposite would be the 3, adjacent would be the 2, so opposite of this angle A would be 3, and this would be 2. I could have put the A down in the bottom, and then those would switch, right? So then I can use Pythagorean theorem. It says a squared plus b squared equals c squared, or x squared plus y squared equals r squared. We can find our hypotenuse. Oops, this is an equal sign. And so this is 4 plus 9 equals r squared, so that's square root 13 is r. And then now I can go ahead and find sine of that same angle. So sine of this angle A would be opposite over hypotenuse. So sine of tan inverse of 3 over 2 is equal to 3 over root 13, which I need to rationalize that root 13, so I get 3 root 13 over 3. Okay? And then technically, since I don't know what quadrant I'm in, it'd be plus or minus, right? Because I don't know what quadrant I'm in. Okay. Okay, so the second one we're looking at tan of cosine inverse of negative 5 over 13. So remember, this is just an angle, right? So cosine is adjacent over hypotenuse, right? So really the A is negative 5 or positive 5, and then 13 would be negative or positive. Just one of them's negative. It really doesn't matter which one. Usually your hypotenuse is always positive, so you could just always do that. Leave your hypotenuse is always positive. Okay, so there's our H, there's our A. Now we can use Pythagorean theorem, right? Here we would always our adjacent squared plus our opposite squared equals the hypotenuse squared. This is the same as a squared plus b squared equals c squared, or x squared plus y squared equals r squared. So I'm going to take negative 5 and square it. Remember, whenever you square a negative, you will get a positive. And then we don't know O. That's not 0, that's an O. So maybe I should do opposite. Okay. And then H is 13. 13 squared is 169. And then, so then I'm going to go ahead and subtract 25. So I get 169. Subtract 25, that's 144. So that's 144 is equal to the opposite squared. So that means the opposite side is equal to 12. So now I have all three sides of my triangle. You could draw a triangle if you want to. You don't have to. You can just do this. And now I'm finding tangent, right? So now I'm finding tangent of that. So tangent is opposite, which is 12, over adjacent, which is negative 5. So there you go. So there's your answer. 12 over negative 5. Now because I square rooted that 144, it's really plus or minus, right? So this is really plus or minus, so that negative really doesn't have anything to do with it. So this, you can just put plus or minus right out front, and that's fine. Because you know cosine might be negative, but maybe tangent, you don't know if tangent's positive or negative, so you need to put plus or minus. Okay, so here's a little more complicated one, but it's not that complicated. It might look complicated, but you got to think about it. Arctan or inverse tangent or inverse sine, those are just angles, right? So this is just an angle A, and say this is an angle B. So now we have this cosine of A plus B. Well, that's just the sum formula for cosine, right? Cosets range of the date, so she goes with her sister, right? And she thinks their signs are different. Sine of A, sine of B. Okay, so A is just arctan of root 3, so cosine of arctan of root 3. So remember, that's finding the angle, and then I'm timesing that by cosine of arcsine of 1/3, and then subtract sine of A, so sine of arctan of root 3, and then times that by sine of arcsine of 1/3. Running out of room there, 1/3. Well, remember, these are finding the angle. So what's the angle that gives us a tangent of root 3? That would be a 60-degree angle, right? So 60. So now I'm finding cosine of 60. This one I do not know because it's 1/3, right? So that means I want to do sine is opposite over hypotenuse. So my opposite would be equal to 1. My hypotenuse would be equal to 3. I can use Pythagorean theorem, and we get the adjacent side is equal to square root 8, or 2 root 2. So I'm using Pythagorean theorem there. So now I can go ahead and find cosine of that same angle, which cosine is adjacent over hypotenuse. So I take my adjacent, which is root 2, and put that over my hypotenuse. Oh, my adjacent is, sorry, 2 root 2 or square root 8, whichever one, over the hypotenuse, which is 3. Or 2 root 2 over 3. We'll do 2 root 2 over 3. Okay, so that's that one. Now I can find sine of arctan, so I'm just finding sine of 60, right? Because I already figured out what arctan of root 3 is. That's 60, so this is sine of 60. And then sine of arcsine of 1/3. Well, I can use these numbers, the opposite, hypotenuse, and adjacent, from what we figured out of cosine, and just find sine, which is opposite over hypotenuse, so that's just 1/3. So this is just 1/3. Then I'm timesing these. I'm timesing this one by the 2 root 2, so cosine of 60 degrees times by 2 root 2 over 3, and then minus sine of 60 times 1 over root 3. Now I don't times anything here. I got to figure out first what cosine of 60 is, which is 1/2, and sine then would be root 3 over 2. 2 root 2 over 3. Now I can go ahead and multiply. So 1 times 2 root 2 is just 2 root 2. 2 times 3 is 6. Root 3 times 1 is a root 3. Oh, I did that again. Keep on trying to put a 3 there. That's a 2. And this is over 6 as well. Now I can combine. I can't really combine the tops, but I can keep it as a binomial on top, and then the denominator 6. So there's my answer. And so that is all done with that. So if, real quick note, anytime you have this, so anytime you take sine of arcsine of x, your answer will always be x, or any of the trig functions. And the same is true as arcsine of sine of x is equal to x as well, right? They're inverses, right? So they're just going backwards. So I'm taking arcsine of sine x. Well, sine x just gives me an answer, right? Gives me an answer, and then I'm asking for, okay, what is the angle that gave me that answer? That's what arcsine is asking. So sine is saying, okay, hey, I'm going to give you an answer, and then arcsine is saying, hey, what's that number that you plugged in that gave you that answer? Well, that's x. Okay, so just a little quick note. Okay, here's another one. So arcsine, remember, that's just an angle. So this is just an angle. So then you have tan of 2a. Well, tan of 2a, isn't that a formula that we can use? It's just 2 tan of a over 1 minus tan squared of a. So I got to find tan of a, right? So that means I need to find out tan of arcsine of 2/5. So I need to find tan of arcsine of 2/5. Do I know 2/5? Nope. So I'm going to use, I can use the triangle, or I can say, okay, sine is opposite over hypotenuse. So that'd be 2 over 5. So the opposite is 2, the hypotenuse is 5, and I want to find tangent, and tangent is adjacent, sine, tangent is opposite over adjacent, right? So I need to find the adjacent side. Well, I can use Pythagorean theorem, so I can square these two. So that'd be 4, and then I'm going to take 25 and minus that 4, so that's 21, so that's square root 21. Right, is my adjacent, so that means tan of a would be opposite, which is 2 over square root 21. And you can go ahead and rationalize that now if you want to, so that's 2 root 21 over 21. So there's my tan of a, right? So then I can plug it in for tan of a here, and then down here I'm going to have to square it, right? And since I'm going to square that one, I'm going to put this bottom one in for this one, 2 over root 21 at the bottom, because I want to square it. That means it's going to get rid of my square root sign rather than doing this second one where I'd have to square 21, because I don't want to take 21 times 21, even though it's like 242 or something like that, or not even, no, 442 or something like that. I can't remember though. Okay, so this is 2 times the 2 root 21 over 21 But on bottom, I'm going to do the other one because they are the same, but it's being squared, and that's going to get rid of that radical on bottom there. So we get 4 root 21 over 21 divided by 1 minus 4 over 21. Now I can go ahead and I'll go this way with it. And this bottom one would be 21 over 21 minus 4 over 21, which equals 4 root 21 over 21 over 17 over 21. Now I'm dividing by a fraction. So whenever we divide by a fraction, we just flip the denominator. We only flip the denominator, right? So that would be 21 over 17. So then these 21s cancel out. That was kind of my point of doing that way too. So eventually the 21s would cancel out. And then, so there we go. There is my answer. And we are all done. Okay, so here's homework on page, starts on 683. Well, technically number 53 starts on 685. So 685. So we can start here on number 53. We're going to go ahead and use a calculator, and we're going to find out what this is. Oops. So on our calculator, we're going to do sine inverse of 1 over this number. And so that will give us our approximation in here. And then we want to look at, probably it's asking for in decimal degrees, so we're going to put this in degrees. So make sure your calculator is in degrees for these problems. And so we're going to get 30.99 degrees. Let's go ahead and round there. So there's our answer to number 53. Number 65, same kind of thing, except for, of course, we're going to do cotangent. So we're going to write as tan inverse of 1 over that. And then we're just going to make sure when we do that, that if we get a negative number, we need to be between 0 and 180. So if it's a negative number, we need to add maybe 180 to that. So we get like negative 47.33. And so then we need to go ahead and add 180 to that, because that will get us into the first and second quadrant, right? Because we're in the fourth. This is in the fourth. So this is in the fourth quadrant. If we add 180, that's going to put us in the second quadrant, which that's our range, right, between 0 and 180. So that will get us there. So if we add 180 to that, that's going to get us to 132. So 132.67 degrees. And so there's our answer for number 65. Okay, so here we go. Finding on number 79, we have arc tan of arc cosine of 3/4. Well, 3/4 is not on our left hand, right? So we can use Pythagorean theorem here to find all our sides, right? This is going to be x, and this is going to be r. So we got to find y. So that'd be 9. It's a 3, 4, 5 triangle. Actually, it's not a 3, 4, 5 triangle. If that was a 5 on bottom, that would be a 3, 4, 5 triangle. Okay, so we got to square this. We don't know what y is. We're adding to get there. We're adding to get there. And then we have our r squared, which is 4 squared. So 9, 16, y squared minus it, y squared equals 7. So square root 7 is y. So there we go. So now we find tangent. Tangent is y over x. So that'd be root 7 over 3, and it's plus or minus, because we don't know what quadrant that is in. Okay, so there would be number 79 for you. And then here we have cosine of tan inverse of -2. So -2, we don't want to use a calculator, so we can put this 2 over 1. And then we have tangent, so that's opposite is -2. So that would be your y equals -2, and your x is 1. So we can use Pythagorean theorem, square, square, add, we get square root 5, right? So r is square root 5. And then we're going to find cosine. Cosine is x over y, so that's a 1 over root 5. So root 5 over root 5. So we get root 5 over 5, and then plus or minus because we don't know what quadrant we're in. Okay, so here we have or sine of 2 times the tan inverse of 12 fifths. Remember, this is just an angle, so we're really finding the double angle of sine. So that's what we're finding here. We can go ahead and find this angle. So we can do tangents opposite over adjacent, right? So that's 5 squared plus 12 squared equals r squared. So that's the 169, right? Because it's a 5, 12, 13 triangle. So 169, square root that, so it's 13. And then we can go ahead and use our double angle of sine formula. So that's 2 times sine of a cosine of a. So sine of a would be opposite over hypotenuse, so that would be, or y over r. So that would be 12 over 13, so 12 over 13 for that, and then cosine would be 5 over 13, times those and times it by 2. So 13 times 13 is that 169. 5 times 12 is 60. 60 times 2 is 120, so this is equal to 120 over 169. Okay, so here we go. Last one, we have cosine of tan inverse of 5/12 minus tan inverse of 3/4. And so this is just a A and this is just a B, right? They're just angles. So we're really writing the difference formula for cosine. So cosine of tan inverse of 5 over 12. So again, that's a then times cosine of the second. So this one, the first one's a 5, 12, 13 triangle, and the second one's a 3, 4, 5 triangle. So switch the sign. So we can do Pythagorean theorem on both of those. And then sine of tan inverse of 3/4. So once we figure out, oops, that goes there. Once we figure out one, oops, forward. Once we figure out one, we can figure out the other because it's the same angle, right? This is the same angle as this one. This is the same angle as this one. So once we figure out one, we're good. So 5 squared plus 12 squared, again, is 169. And then square root that is we get 13, right? So my adjacent would be, or my x, sure, x is root, or 13, sorry. This one's a 3, 4, 5. 3 squared and 4 squared is 9 plus 16. 9 plus 16, 25. So square root, we get 5. Right, for our, this is actually for our r, and this is for our r as well, and they'll be the same for those two angles as well. So really, we're finding cosine of this right triangle. So cosine is x, which would be on bottom, 12 over r, 13. This one would be cosine of the same thing, right, or a different angle. Cosine would be x, which is on bottom, 4 over our hypotenuse, which is 5, and then plus sine of that would be, sine is on top, so 5 over the hypotenuse, which is 13, and then sine of 3/4, which is the top, over our hypotenuse, which is 5. So we get 13 times 5 is, what's that, 65, and that's 48, plus 15 over 65, so that is 63 over 65. So you notice some of these answers are the same that you deal with because we deal with a lot of the same triangles because there's only so many Pythagorean triples. Well, there's probably lots of them, but only so many that we know off the top of their heads. Okay, so that's it for section 5 of chapter 7.